Hello everybody, this video aims to help you with the introduction to the bone histology. So as other types of connective tissues, the bone tissue also is made of cells and matrix. Let's start with the cells. And the first type that we mentioned are the osteogenic cells. Osteogenic or osteoprogenitor cells that come from mesenchyma as the source of all the other types of cells, namely osteoblasts. And the osteoblasts are synthesizing bone matrix. So typically you will find these cells on the surface of bone trabecules. They are producing bone matrix, which at first is not mineralized, and later on these cells will become trapped inside and mature and differentiate into another cell type called osteocyte. But that's usually a situation when the surrounding matrix is already mineralized. So these are osteoblasts. They synthesize bone matrix. That's their task. The newly produced bone matrix is not ossified yet. It's called osteoid. Later on, the matrix is fully mineralized. Newly produced bone matrix, and the osteoblasts differentiate into cells called osteocytes. So this is an osteocyte. Differentiated from an osteoblast. An osteocyte has different morphology than its mother cell, than the osteoblast. Namely, an osteocyte has many cell processes it's a cell nucleus, and these cell processes are spreading through the bone tissue. They branch. So the whole bone tissue is very densely, or contains a dense network of these processes. Okay, here's the bone matrix, right? Everywhere. If you would look more closely, you would notice that these processes run through microscopic canals where these are surrounded with a fluid called interstitial bone fluid. And as this fluid, as all the other fluids, is incompressible, it helps to transfer and propagate mechanical stimuli across this network to the cell body of the osteocyte. So here is the wall of the canals, and here's one of these processes inside. So this is the osteocyte process. Surrounded by interstitial bone fluid. And it runs through the bone canaliculus. If you have more these canaliculi, the plural is canaliculi. Another cell type occurring in the bone is osteoclast. An osteoclast is a specialized type of macrophage which is a long microvilli. It has many nuclei, so it's a multinucleated cell, and it releases enzymes that are resorbing bone. So that's why you find the cell usually in a resorption lacune, where from this microvilli enzymes were released. So we have multiple nuclei here. There are enzymes being released. These enzymes are destroying both organic and the mineral component of bone. So there is this resorption cavity as a result. It's called Hauschip's lacune. Hauschip's lacune. By the way, if I go back to the osteocyte, the cell body also resides in a cavity called lacune. Cell body resides in a cavity called osteocyte lacune. So that's a different meaning of the same word. Okay, so far the cells. And what about the matrix, the bone matrix? First, the organic part is produced. The organic component, also known as the ossane, mostly consists of type 1 collagen, these thick bundles of collagen fibers, and glycosaminoglycans, and various bone glycoproteins, known also as the bone sialoproteins. A good example could be, for example, osteocalcin, marker of newly produced bone matrix. The organic component becomes mineralized by deposition of crystals. These form the inorganic, or if you prefer, mineral component. And the main mineral is the hydroxyapatite. And a simplified formula, because there is a whole variety of forms of crystals of various composition, but the main and simplified formula would be: we have a calcium cation, we have a phosphate group, and we have the hydroxy group. So a stoichiometric ratio, again simplified, would be like that. And on the surface, there is a variable amount of water molecules adsorbed. We should take in mind that these calcium ions could be in some crystals replaced by magnesium and possibly also strontium cations, while the hydroxide anions could be possibly substituted by fluorine anions. Another mineral of the bone, a minor one, is calcite.